Start. Yeah. All right.
Yeah.
Hi, everyone. Welcome to the ACM SF meetup. We're excited to be hosting you today. I'm Ria. I work as Senior Engineering Manager at Medible, helping bring therapies faster to patients. Joining me here is Akash, who works as Principal Software Engineer at Twilio. For those of you who don't know about ACM is a nonprofit organization that brings together computer science researchers, students, and practitioners to talk about cutting edge work in computer science, like the exciting talk we have lined up today. Without further ado, I'll introduce our speaker today. Dr. Shouwei Chen is a software engineer at Alexio. Before joining Alexio, Shouwei received a PhD degree from Rutgers University. Shouwei's research focuses on the co-design of memory-centric computing frameworks with in-memory distributed file systems in large-scale environments. And with this, over to you, Shouwei.
Yeah, thank you, Ria. And really nice to see you guys. And since we don't have much people here, feel free to stop any time if you have any question. And previous, all my colleague being will co-present this talk with in this event, but actually he's get very bad cold nowadays, so I will be the only speaker today. So Ria already gave some introduction to myself, and today's topic actually we want to share how we build the unified data analytics and AI at any stack and any cloud. Yeah. And this is a short introduction by myself. Actually, nowadays, I'm not only the software engineering as a co-maintainer at Alagio, also I take responsibility for the community product manager at the open source team. Yeah, Alagio is the open source project actually start from UC Berkeley and lab from the 2014. And then nowadays we already have more than 1,200 contributors in our community. And we're also recognized by the Google, which is the top 10 most critical Java-based open source project. And we have more than 9,000 of the Slack member in our Slack channel. And feel free to join this Slack channel. We are very active there to answer any technical question, no matter it's troubleshooting or it's like a developer co-development question. Yeah, before we dive into the real detail how we implement the system, I want to raise the question first. So why the data platform these days are very complex and it's not so easy to use? And let's look at some common pitfalls we are observed in the industry. And first of all, there's more and more data is being generated and data is being stored in silos, which means like you have to copy and manage data all over the place. It's very costly. And you have to do the manual work to do the error cloning and cause a lot of delays. This is what we saw for almost every of the customer that they have to deal with this kind of data silos in their environment. The second problem is that as many different teams need access to the data, which means it's need a lot of support for the new applications and the corresponding different interface to access this kind of data. For example, previous people really bite into the Hadoop ecosystem, and nowadays people converting to the Spark, Flink, or even like PyTorch, TensorFlow, all this kind of application. So you have to have certain storage or interface to support all this kind of framework. But this work actually need a lot of time and effort to optimize it. And on top of that, actually our technical industry is progressing is very fast, which has been create new compute and storage technical every 3 to 8 years, which means actually it's compute framework as a keeping evolution, and you cannot use a single compute or single storage to meet all these kinds of requirements. Okay, so let's take a look at what is the traditional data infrastructure may look like or involved into something like this, which is very complex and slow down the business agility. Or in many cases, actually, you can see here, the data infrastructure starts with the on-premise environment for analytics, as depicted by the box here. And it's usually binding with the Hadoop ecosystem with the different components like HDFS, Hive, Spark, or Presto, this kind of thing. Yeah. And then many data team may start to introduce new kinds of application like machine learning and the new storage solution suitable for the application as depicted by the box here, actually at the bottom right. And actually it's introduced the new computing framework and introduce the new storage into it. And finally, adoption of the single or multi-cloud adds even more environment to manage it, as depicted by the box on the top two. Actually, because this kind of complexity, you have to deal with all this kind of not only the different computing framework and different storage system, but also you have to deal with this called a heterogeneous architecture in your environment. Okay, so there is very strong demand for this kind of simplification because the current data platform is so complex. First, there is a need to unify data silos, which means you don't want to, when you integrate every computing framework with the storage, you don't want to develop the single interface to adopt all of them. So support multiple APIs and a common user experience to meet the demands of analytics and AI application is very important. And the second, with storage separate from the compute, the platform need to be provide easy and efficient way access to data, regardless of the location of data. As we can see in the previous slides, for example, if you run with the data on premise and you want to also get the benefit to run the TensorFlow training or the PyTorch training at cloud, you have to move the data from the on-premise data center to the on-cloud environment, which is very expensive and not so performing well. So actually, you have to find some way to overcome this kind of problem. And lastly, the solution need to be environment agnostic and also be multi-cloud ready to accommodate the future state for computing and the storage technology to make your business more agility. So with all these demands in mind, we have introduced a new layer between the compute engine and the storage system. We call it Alashu. It's actually for the analytics and AI in the hybrid and the multi-cloud environment. The new layer provides the complete virtualization across all of the data source to serve data to application who don't need to care about the location of data and also care about the interface of the application. And the solution we built is applicable across environment, whether it's in cloud or in premise, it's bare metal or containerized. Yeah. So after this, let's see what is the new data platform looks like. The main difference is that I let you in the middle. So the complexity of among the various data silos is removed. In each environment, as long as the application interact with Alashu, you don't need to worry about the data is stored and how to move the data around. So you don't need to do many different data replication and do the data error proning after you move the data. And the number of copy being eliminated is not just you copy the data from one region to the other region. You have to keep all this copy. Actually, Alashu will keep this kind of data in your computer region and just discuss it when it's not necessary. Yeah, this is our core feature. The first one is called the distributed caching. Actually, this is a feature to meet our requirement to run anything regardless of where the data is. So, for example, if you run some data in the main IO or Ceph, actually you deploy in your on-premise data center, and you also want to get benefit to run it in the AWS environment with their EMR, or even like Databricks or Starburst. Actually, you can just keep this data in your on-premise data center, and from the Alashio side, actually you can catch all this kind of data and serve this data to the Spark operational application. With this kind of thing, you don't need to like retrieve the data from the remote data source multiple times, because as we know, like maybe you just ingest 1 terabyte of data in your data center, but when you consume data, it can be 100 times larger than that. If you don't use any caching technology there, actually it will be super expensive for this kind of remote ingress cost. Okay, the second one actually is meets the requirement to simplify the architecture of your data platform. It's called the file system namespace virtualization. As you can see here, just imagine in the previous world, if you want to adopt with the HDFS interface, maybe it's called HDFS native interface. And at the second point, actually you adopt some application called Cortex or whatever, it's only supported S3. So actually your storage cannot serve the data request to this kind of computing framework. Actually, you want to say like, I have to implement another data interface to serve this kind of application. So it will take super long time, and people also very suffering about it because actually many people just move from the Hadoop world to the cloud world with the different standards. But with our system, actually we provide the necessary northbound and southbound API to your application. You don't need to worry about it. And at the same time, you can just mount this kind of namespace. For example, here it's like HDFS service sales data into Alashio namespace with the data, and also AWS S3 bucket into your like root path. Actually, you can just access the Alashio namespace to fetch all this kind of data. And the only thing you need is Alashio client and maybe also S3 API. So nowadays, like thousands of the company are using Alashio in their environment. It's including 7 out of the 10 largest companies by market capacity and 8 of the top 10 largest internet companies. Actually, we are seeing success across verticals, which including a technical company leading by the way, and also we regularly see there's also more finance company or telecom and media company are start using Alashio. Yeah, I stop here a little bit to see if any question. Yeah, feel free to interrupt me if you have any question.
Yeah, you can post your questions on the Q&A.
Mm-hmm. Okay. Afterward, I will give some use case study about Expedia Group. Let's see how they like eliminate this kind of data silo problem here. And if you're interested, you also can look into our blog here, and actually it's include more number and more graph and more explanation here. As you may know, Expedia Group is an American online travel shopping company for customer and small business travel. Actually, they build like a very large travel company worldwide. And actually, they call them, it's called like brand world. It's you may know like this is a large company, but you may know they acquired a lot of different company to build their brand world. They manage the data in the cloud and provide a lot of their service across the region. For example, here, as you can see, actually they have the US West 1, US East 2, US West 2, and also US East 1 as a main region, which means they run their application not only in a single data center, but also from the many different regions across the world. And another problem is in the brand world of Expedia, they have family of independent, very independent running company and it's including such as Hotel.com, Verbal, and many other different companies. Actually, it's created a lot of the data silo problem for them. Because the reason of this kind of data-driven application, for example, they have a lot of legacy data at the US West 1 with the hotels.com, and it's almost impossible to say like you want to transfer all this kind of legacy data from the one satellite region to the main region. It will just mess up your environment and cause it also takes a super long time and very huge cost to do it. And so actually with this problem, actually it's enforced them to think about what's the solution to solve this kind of problem. Yeah. First of all, actually, they come up with the idea. It's a very typical way how you solve this problem called data replication. For example, if we want to run some data analytic at the main region, for example, here is US East 1, with all this kind of company's data, you want to replicate the data from the satellite region to the main region, then you do the compute. But actually, it's caused several different problems. The first of all, actually, it's get very poor performance, and it also caused a lot of availability issue. So have a replication not just means like you replicate the data that's done. You have to do the error pruning, and you have to do the validation, and you have to make sure you notify the user, say that data is already ready, you can consume it. So which means that the data is inconsistent between the main data region and the siteless data region for a long time. This time can usually come from like several hours to even whole day. So it will not so user friendly, and people will really complain about the data availability issue in their company. And the second problem is about the error prone. Because you have to validate all this kind of data, which means when you add one data pipeline into it, you have to do some manual setup for all this kind of thing. For example, if you have maybe you onboarding first the business line with the US East 1 to the US East 2, US West 1 to the US East 1. So you set some configuration to make sure it can happen. And afterward, if there's another business line said, I also want to some data from the US West 1 to the US East 1. So actually you have to do a lot of manual work to make sure people can access the data and you do the data validation, which is a very team costing. It's not only for the AWS cost, but also for the labor cost. And the third one is because of very high S3 ingress cost. Ideally, actually, when you move the data, you can just move just need data from the US West 1 to the US East 1. Just to give you an example here. For example, you have a large table with 10,000 of partition in a table. Maybe you just want to move the latest 7 partitions, which represent the last week data to the main region. But actually, in reality, you cannot predict it, which means in their real case, they can have a table more than 100 terabytes of the data in a single table, but when they move it, they cannot predict how many data they really want. So in the worst case, they have to move the 100 terabytes of the data from the original satellite region to the main region, which is very costly. Yeah, this is the way how they deal with this problem. They have one open source project called the Circle Stream to move all this kind of data from the different data lake. It can be the data lake D to the replication data lake to serve all this kind of application. But because of this problem, actually, it forced them that they think about the replication is not sustainable, and they have to focus and to rethink a long-term solution to mitigate this kind of issue, and including improving the latency, reducing cost for cross-region data access, and decentralized data lakes. Yeah. Afterward, actually, they introduced the Alashio in their system. What they did before is, as you can see in previous two slides, they just like replicate data from the satellite data region to the main region. And nowadays, they just mount the satellite region data lake to the main data lake. As we can see before, we provided the first of all, we provided the Unify namespace. And the second, we also provide the caching. So it provides a certain of the benefit here. First of all, it's greatly enhance the query performance and also enhance the data availability issue, like solve the data availability issue. Data is now like immediately available to user. You don't need to worry about the latency after one long process of the manual replication and data validation. The immediately here not means like sub-millisecond or sub-second. It's usually happen in several minutes. Then you will see your data in the main data region. And performance is also significantly increased because actually we do a lot of optimization for this kind of framework. And also you don't need to overcome the data access from the satellite region to the main region. Yeah, and the second one actually is easy of use. By integrating with Alashio, actually you can combine all this kind of data lakes from S3 in different regions. You don't need to do the manual replication. And as I mentioned before, you also don't worry about how many data you want to copy. So we just keep every metadata in sync, but actually the data will not fetch into the main region until you really need it. So which means like previous problem, you only need maybe the hot data for you is only past the 7 days or past the 30 days of data. We will not need to replicate the whole table for maybe several 10 or 20 years data into your main data region to consume them. And at the same time, actually, because Alashio itself will do the error prone and we will validate the data consistent from the satellite region to the main region, you don't need to worry it anymore. And the third benefit actually for this architecture is a significant cost saving because you know like S3 also charge for the increased cost and also it charge for the across region data cost and also it's a charge for the operation. If you serve your own service in the cloud, actually don't need to worry about it. So if you increase 1 terabyte of data and you just caching this 1 terabyte data, actually it's all the operation and all the data serving actually it's come from the Alashio itself. It's will not like reduce like cost so many data serving from the S3 itself. Okay, I saw one question here. What's the security model for data sharing here? Is it same as source bucket in S3? Yeah, it's a very good question. Actually, we provide a lot of different security model here. First of all, in Alashio itself, actually we provide ACL authentication, so which is same as the HDFS itself. And at the same time, we also provide the Ranger integration and also provide the S3 integration for this kind of thing. So which means when you have the external store, like secret store or whatever, this authentication, you also can pass by this kind of framework to make sure that means sure like you will like also respect the S3 or the Ranger this kind of policy when you access data in the Alashio. Yeah. And this is the new architecture looks like in the diagram here. And for them, actually, they built one Alashio cluster at the US East 1. And nowadays, they even like, when we write this blog, actually, they don't have the satellites, the Alashio cluster at the US West 2, because they want to move all the data into US East 1. But finally, they realize it's harder and it's almost impossible to move from the satellite region to the main region. So actually, they also launched the different data access from the satellite region for the Alashu. For example, even for the satellite region nowadays, they can consume the mainstream data from the Alashu itself. Yeah. Yeah, that's all. And we really welcome to you to join our Slack channel. And actually, we also post our event, for example, cooperate with the ACM San Francisco nowadays. And we will also post this kind of event at our Twitter and LinkedIn. And maybe more question?
Hey, Soid. So this is Akash. I was curious to know, what's the lag generally if there is a data change in S3 happening and between the LXCO?
Sorry?
So when the data source is changing, like the data set in the S3, if that's changing, it's getting mutated. How is it, like, what is the mechanism we use to update that in LXCO? And how, what's the latency between that?
Okay, it's a very good question, and because actually Alashio itself is decoupled from the, for example, S3 or HDFS, it's really rely on the under storage. We call the UFS under file system. What kind of capability they can provide? The general truth here is actually we will do it periodically. So which means like if you do the metadata sync, we call it metadata sync to make sure the metadata is consistent at all layer. It usually will have several minutes of the delay based on your configuration. And after it's expired, we will do the metadata sync again for this kind of path. And at the same time, if your file system can give some event tracking, like HDFS, they have one mechanism called the iNotify, which means when you delete the data or insert new data or update the data, actually they can allow to notify to the upper layer application. Then we also have one sync called active sync to aware of that. So that happened where like immediately when the file system change the data, Alashu will update the metadata corresponding like metadata in Alashu namespace.
Thank you. And one more question I have is that since you are like mostly HDFS compatible API, so is that like LXU provide appending also to dataset?
Provide what?
Append files?
Append?
Yeah, append this one. So existing file, can you append something like that was done in the HDFS, right?
Oh, you mean update?
Yeah, update, yeah.
Oh, it's a very good question. Actually, yeah, the thing is like we are our interface is compatible with HDFS, and but not only for the HDFS, or we also compatible with the S3 with S3 API and all this kind of thing. But for the update, I assume it means append, right, for the HDFS.
Exactly, yeah.
Yeah, and actually we don't support append, so which means like when you commit this kind of data into a larger namespace, actually it will never change. But if you update the data from the HDFS, we will fetch it again from the HDFS worker to make sure you get the updated data. But we will not follow the append model to update the data.
Okay.
Yeah, thank you for the good question. And any more question about?
Yeah, attendees, either you can raise hand or you can type the questions.
Mm. Yeah, if you have any following question, you also can like join our Slack channel. And after you use Alasho, I'm pretty sure you will have more questions there. And Akash, do you have any follow-up things we want to do?
Cool. Yeah. Thanks for the talk, Shouwei. Yeah, if we will be posting for our next event on the meetup page, so stay tuned for that. And yeah, thanks for joining. Have a good night, everyone.
Yeah, thanks, join. Thank you, everyone.